Alrighty, so this is Open Sesame. I'm going to talk about opening up the Master 175 padlock and some introduction to metalworking. A little bit at home, a little bit heavier stuff that you got to go to a makerspace or metal shop to go to. So a little bit about me. I'm Max Power. I'm the chapter leader for Tool Boston. I like all things security, sociological, psychological, physical, digital. It's all interesting. My day job is an IT generalist or InfoSec, depending on which year you catch me in specifically. The other thing that I spend my free time doing is powerlifting. My favorite place to be is in the squat rack. And by night, I'm Wolverine. So, what are Sesame-style locks? They're locks, padlocks with multiple dials. Sometimes they're built into a container. I don't think I've seen anything that wasn't either 3 or 4 dials. You don't need a physical key for them, and some people like them because you can easily share the access. It's not going to get anybody into trouble, right? What's the combination of that airlock? 1, 2, 3, 4, 5. So, yeah. All right. Yeah, probably. So this is the Master 175 or it's your extension backwards. The Master 175 padlock, for those who haven't seen it. It's a little bit different than other Sesame padlocks. In order to open it, you dial the combination, you push the body into the shackle, pull the body away from the shackle, or let it spring away from the shackle, and it's going to open up. If you're going to change the combination, instead of me trying to explain really technically on my own, Master Lock has a nice little video. It comes with this change key that's the same for every lock. You put it in the lock, it's going to push a bar that's going to separate a flywheel and a dial. Set your new combination. When that's done, you're going to rotate the change key back. Yeah. One extra. Rotate the change key back, test that the lock closes before you scramble the dials, and then scramble the dials and close the lock. Why do I care about this lock? Or why should you care about this lock? Somebody came back from New York City Maker Faire and handed me this lock, and they said, a little girl showed up, and she said, I don't know how to get into this. Can you guys get into this? And the New York guys and the other guys who were there, I don't know how to use PowerPoint, said, well, we can open it. We just can't tell you what the combination is. But we should be able to decode this. So kind of put this thing in my head, and I was like, I really have to figure this out. Like, if somebody can do it, but nobody knows how to do it. So I looked around, I spent a lot of time, found a bunch of YouTube videos. It wasn't working. But in the meantime, this lock showed up in all sorts of places. For some reason, everybody loves to use it on gates. There's some really expensive cars back there that this is protecting. This is an electrical box at a telco site. You'll also find your telco providers put it on their trucks. These are carts that are sold in a certain store that it's a certain fruit that are not made by that company, but kind of like, oh, here's this one vendor. Yeah, they all get shipped with a bunch of these locks, and they all get shipped with a bunch of those locks, and so those are in schools everywhere, and the bypasses for these are on YouTube. The other thing is they are at the gates of the cell sites, and I've had people come up to me and go, oh, those locks, yeah, those are used all across the state. There's 1 or 2 combinations just so fire and police can get into it for a safety emergency. What? That's what's on the fence of our cell infrastructure. So, you've got this lovely combination lock. You can share the combination. It makes it appealing, but chances are, as we are people in large places, we're going to share those combinations. So what else are those combinations on? Maybe like a $350 simplex high security lock for the shack inside the cell site has the same combination as the $15 Master 175, people's cars, their house doors, maybe the alarm panel. So reasons why you might want to decode it, why you might not want to use that same combination, or why that might be a problem. Here's a breakup of all the pieces. there's a shackle here. These are the two pawls that go into the cutouts in the shackle. This spring has the rod through it and goes into holes milled into the shackle to push the pawls apart. This is the actuator. The tang at the top rests between the shackles, the pawl normally, and the spring pulls the actuator through the body and hooks in there. The fingers on the actuator rest on the flywheels that lock into those little notches of the dials, and this is just a bottom cap. Here's another view of the lock partially assembled. And you can kind of see how everything fits together down there. It's hard to see, but the flywheels are on the right. So, what if you don't care about the combination and you just want this thing open? Good news. There's a bypass for it. A bypass is a operation with which you can manipulate the actuator, the tang, at this point to open the lock without moving the dials to the correct combination. So for the bypass, we're going to take a hook lockpick. We're going to insert it above one of the dials, push the body into the shackle, and that's going to pull the pawls away from each other so they're not exerting pressure on the actuator. And sweep towards the direction of the hook's curve as you pull the hook away from the lock body. Release the body and it'll open. If that wasn't clear, which wouldn't be surprised if it wasn't. Here's a video. The lock's closed. I'm going to get the hook in there and grab for the finger on the actuating plate. And you can kind of see the plate come up again. All right. So, guess what? There's not one way to bypass it. There's two. So there is either feeler gauge or something called a mini knife tool or an easy decoder. And you can take that, insert it to the left or right of the dial. Find the one it goes into easiest. It needs to go in about an inch. Push the body into the shackle. Lever the tool up. Release the lock body. And it'll open. So here I'm going to put it's a Peterson mini knife, but I've got some Sirpic easy decoders. And sometimes it takes a couple tries. If it's not going to go in where you're trying, try the other side, try a different wheel. And it just went underneath and came out. There's a little bit right there. So I'm going to push down. You should see this piece move up. There you go. And the shackle popped open. So I spent about 2 months trying to decode this notepad. All right, I think I feel something. Write it down. Move the wheels around. It just kept failing. My next thing, more power. I went to my local makerspace. I found a class to learn to use machining tools, and so I could see the guts inside. Artisan Asylum, it was a ton of fun. Some safety things before I start talking about all the fun tools. Tiny metal flakes are not glitter. Neither of us like having them all over and stuck everywhere. Neither do computers. You're going to want hearing protection if you like your hearing. You're going to want eye protection if you like your eyeballs, because there's parts of metal that go flying. I found breathing protection was needed even though it wasn't recommended. Don't be like this cat and get your tail stuck in the moving parts of the machines. There's lots of motors, rotary tools. It may seem like a good idea to use gloves, but they're actually prohibited in the machine shop. If you have jewelry, necklace, long hair, tuck it all away. Sleeves and bare hands. So some basic hand tools. Files, they come in different sizes and shapes. There's flat, semicircle, circular, triangular, for getting into those corners to match what you're trying to work on and remove metal from. There's something called a bastard file, and that's just a file with really big grooves in it. It's going to remove a lot of metal at once. They're usually huge. They look like they're for bludgeoning. And you can also go to hobby shops and get some really tiny files if you've got smaller parts. File in only one direction, because you need the pieces of metal to fall away from the file. Otherwise, you will be destroying your file and not making a clean edge. Punches, I use and break lots of these. They're used to make a little mark on metal. They're made of harder metals. That way it'll help you get started when you're drilling. Otherwise, a drill bit can kind of skip around as you come down onto the metal. The other thing is there's a lot of locks and other devices that are secured with a pin driven through them. So if you drill through one side, you can use the punch to push the pin out. You're going to want to use a softer mallet because if you use hard metal, you may just end up bending the punch. When you're machining metal, the tolerances are, we're talking thousandths of an inch if you're doing accurate work. Calipers are really important for that. Your standard ruler is not going to work. If you're going to buy calipers, don't get the really cheap ones. They won't be consistent. So you're going to take a measurement, go to try to cut, and then come back, and it's not going to be the same. So spend a little bit more money. The heavy machinery that I'm going to talk about later, a lot of that can be done by the Dremel. It's got attachments for cutting wheel, some end mills, some drill bits. You can put it in a rig to make it stable. I wouldn't recommend trying to drill or mill by hand with the Dremel. You will probably end up digging it into your skin or just all over the piece of metal. You can get them cordless, corded, or an adjustable speed. If you're going to work on metal, get the adjustable speed because it's important to be closer to the appropriate speed for cutting your metal with the tool. You don't want to go so fast and heat up aluminum and have it start to get kind of liquidy. And then, like grinding stones, it will just meld onto the grinding stone. Other things that are really important to have if you're going to go do some metal work, a Sharpie. Pencils doesn't show up so well. So you want to Sharpie it, and pliers for pulling out pins and other junk. All right, the fun stuff. This is Bridgeport J-head metal mill for manual milling. It can also do plastic. When you're talking about milling, you're talking about reducing metal and taking off little pieces at a time. It's going to be a side-to-side motion instead of plunging down like a drill. It has an x-axis, a z-axis, and a y-axis. And there's a vise mounted in there. You can use it as a drill press. I'll explain a little bit more about that later, and that will plunge a drill. If you're going to change which axis you're working on, you should only work on one at a time. You should come away from the part. It's very easy to get confused and go in the wrong direction and then take a chunk out of something you didn't want to. The mill gets collets put into it, which screw onto a very long rod that goes through the head and then hold on to end mills, not drill bits. These are flat at the end, unlike the drill bits, which come to a point. And they have multiple flutes going through them. There's different numbers of flutes. There's different types of materials. The end mills are usually made of either high-speed steel or carbide with some sort of coating. The most common one I've seen is Alton. If you are trying to go just deep into a recess, you're going to have to come back up occasionally to allow the metal chips to clear. They will try to come up those flutes, but not always. As far as materials for the Master 175, when I was cutting this, Master doesn't publish what it's made of exactly. So I had to guess, and I had to chat with some of the other machinists, and the body is aluminum on the most common one, and the inside is copper. The pin, if you happen to hit it, is hardened steel. So that's not as much fun. That should say drill bits. All right. So don't put end mills in the chuck. Like I said, you can use the milling machine as a drill press. There is a chuck you can put in instead of the collet for the end mills. The chuck is meant for a drill bit that's going to go down, not an end mill that's going to be working against metal side to side. They can slide out the side while going at high speeds, like 10,000 RPM, and it's just not fun. When you start cutting on the end mill, it's important to know what material you're working on, have some idea. You don't have to know exactly what kind of steel. You think you know what kinds of steel are out there if you don't spend a lot of time in metal, and then you look and you're like, I don't know which one of these steels. There's like 10 different ones, and they've all got hardness values. What is the end mill that you're using in there? What's the diameter? What's the length of the flutes? What sort of material? Is there any coating on it? And all of that, you're going to either have to consult a machinist handbook to get the values for the feed speed and the rotational speed, or there's some apps out there since it's just a table. The feed speed is going to be how quickly you feed the piece of metal through the end mill or past the end mill. And the rotational speed is how fast the end mill is turning. That's set with some pulleys, or depending on how old your machine is. On mine, it was I had to unscrew some motors and adjust belts. Another tool found in the shop is the bench grinder. It's a high-speed rotating stone. You're going to want to take the piece and rest it evenly on that little platform, hold it up against there to have the stone remove metal. It's good for finishing or removing smaller amounts of metal. Don't try to hold it up against the wheel away from it. You're just going to get caught on something and it's going to go off to the side. There's going to be sparks, so keep your safety goggles on. This is for crunching fingers. This steel beam here moves down when you pull this lever. It exerts a lot more force than it looks, and even going at slow speeds, I've had some not fun accidents with my finger. I've used it for either putting pins back into locks that I've knocked out or using a screw to knock them out of a partially drilled lock. Vices. So there was one on the, there was a vise on the end mill. It's really important to hold the pieces in place when you're working on them. If you're trying to cut something really accurately and it keeps moving, you're not going to cut where you want to cut or how far you want to cut. This can be a trade-off when you're working on something like a padlock that's assembled, that's made of aluminum, which is a very soft metal, that also has air inside, because you can easily end up crushing the lock and either not cutting an even surface or not having it operate afterwards. The mill has one attached to it, hopefully wherever you see a mill. If you're doing something with a Dremel, I would not use the plastic suction cup one that you see a lot of Locksport stuff people using, or for soldering. You want something a little bit sturdier. Those will move around. It's important to not do what's in this picture, which is have your piece below the top of the vise, because otherwise you can accidentally cut your vise and it's no longer flat and it's no longer straight. To keep the piece above, you can use these things called parallels. They are very precisely machined rectangles you put up against the walls of the vise and your piece rests on them. Or if you've got a circular piece, you get V blocks that have little V's cut in them, and that will hold on to a circular piece much better than trying to smash it into the walls of the vise. This is a vise on a drill press. It's not bolted in. It's a lot less sturdy. It just has that one vice grip clamp. It's a lot quicker to change stuff out, but I'm only going down. I'm not going side to side. This is just a bench vise. It's got a little anvil there, place to bang metal back together with a hammer, and it's holding on to the bottom cap for a Master 175. You'll see the rest of the photo later. Some things I found doing this. It's really frustrating when your tool breaks and you're in the middle of this project. I've had end mills break, I've had drill bits break, cutting wheels. Make sure if you're going to do one of these projects and you've got little small parts or bits like that, get two. That way, if one breaks, you can keep going and you don't have to pack everything away, or run out to the store, or order something on Amazon. Milling, and this is all a subtractive process. If you take away too much, you're going to have to go learn about welding to put stuff back, and that's not even going to come back very well. So take away less, and you can always come back, remeasure, clean everything off, take a look at it, and then take away more if it wasn't enough. The 1/16 inch end mill is really tiny, and it seemed like it would be great for that cap that you just saw. They just snapped. They needed a feed rate that was too slow, or a machine that went faster than I had, and it wasn't. Somebody warned me, and I tried it anyway, and I think I bought 3 or 4 of them in the end, and I have one that's still assembled because I just stopped using them. I moved to a cutting wheel and a Dremel. So back to the Master 175. When I couldn't decode it, I got a lock out of the trash that somebody had cut. I removed the entire lower ½ inch of the body, and I worked really hard not to cut the dials. I cut it all together, which turned out to be very challenging. And so just a refresher, this is the bottom cap, so I was cutting that away and some of the housing. So I could see the flywheels and the dials in there. In this picture, we've got the bottom of that. Here's the flywheel. There's a gate in here, and it's right in between 2 numbers. It's hard to see 3-dimensionally, but this is a circular part. This is the flat, and it's also centered in the middle of 2 numbers. And here we've got another gate that's centered between 2 numbers. So those little flywheels lock into the dials, and that's how the combination gets set. This is trying to kind of show you the teeth in the dials. The flywheel is currently separated from the dial. So you've got a lock. It's got 4 dials, 10 numbers on each. Should be 10,000 possible permutations. But we really only have to go through 5 on each of them, because we can test each dial individually. We know the gate and the flat on the dial, the center of them, are 5 off from each other. So once we find one, we know exactly where the other one is, or we can rotate the dial 5 times and test for it. So the actuator plate that I was talking about before has those fingers. It's pulled into the body, so the fingers are trying to go down. They rest on top of the flywheels. As soon as the flywheel flat is facing the fingers, the actuator plate comes down. So if you find the flats and you face them up towards the front side of the lock, then you'll have the lock open. So you find them facing down to the body, and then you move them up 2.5 spaces. And I've been able to do it in about 5 minutes for that lock. If you can bypass the lock, take it somewhere, decode it, and then bring it back, that's plenty of time. So those 2 pawls, they go into the shackle. They're supported by a spring that's got a rod through it, so they don't go in funny directions. When you push the shackle in, they come apart away from the tang at the top of the actuator. That plate, the tang sits between them. It sits into the body, being pulled in as much as possible. And like I said, those 4 fingers interact with the flywheels. One thing that I noticed interesting, to me at least, that I hadn't noticed before, was that there's actually parts of the tang come out and go into grooves in the 2 pawls. So it's kind of hard to just hit the lock and have it bounce, unless you're also at the same time pushing the body in. So making a tool to decode this. The standard mini knife and easy decoder weren't working for me. What I did find was some guy who came up with a tool that was 0.02 of an inch thick in feeler gauge. You can get that by going to AutoZone and buying a spark plug gap tester, or you can buy a whole roll of it on Amazon for like 15 bucks. You can cut about 1/2 inch. You can cut longer and make an an angle cut up this way. I don't know, I estimated that at 15 degrees. And then you want to have it go down about 0.374 inches and be about 0.101 inches wide. When that's all said and done, you want to bend the end up at kind of a 90-degree angle out to the right. If you don't want to carry calipers with you or a ruler and you just need to do this somewhere, that 0.101 inches is the depth of the lock housing, and the, what did I say? 0.374 inches is from the edge of the lock housing toward the end of the first number on one of the dials. So if you're going to decode it, hold the lock so the bottom's facing you, make sure the numbers are right side up. Rotate all the dials so they start centered at 0.5, so in between a number, not on one number. And up at the top of the dial, just kind of on the right side, angle that tool in there so you don't ruin the bend. Move it down to the center, see if the tool will go down. If it doesn't go down, go back to the top, move the dial one whole position so you're at 1.5, and come back to the center, test again. If it does go down and you can move it at the same height for the entire diameter of the wheel, then you're on that flat, just leave it there, take your tool out. If it goes down but it kind of feels like you're stuck there, then you're in the gate. Take out the tool, rotate it 5 positions. If you weren't 100% sure, check to see if it's a flat where it is when you're done rotating, and move on to the next dial. So there's a little window down here, and it's just going to show what they're kind of stuck in a gate. And here, there's nothing. You can kind of see the gate because you can see what's going on, but it's going to kind of move around. Sometimes the decoder tool gets stuck because of something in the middle, and here's a flat portion of the dial. Once all the flat areas are facing towards the bottom, rotate them up towards the next full number, and then 2 more on each of them. Push the lock body into the shackle, and it'll pop open if you actually found the flats. So real quick on how I made these cutaways. There's a pin on one side. When you can see where that pin is. Mark where that is off the Master Lock logo. And with the calipers, take those measurements, flip the lock over to the same space on the other side, mark that. And then take it to the drill press. Drill out until you can either see the pin or the pin comes out. Take it over to the arbor press. I used a 3/32 inch bit and 4,600 RPM on the drill press. And then I used a 1/16 inch punch just in case the hole was slightly off. Or you can use an arbor press and something like a screw. You might be able to use the punch too, but the arbor press has a lot of force, so you're more likely just to bend that punch. Set the lock to the correct combination, which if this is a new lock is probably still 000, and just push the shackle in. The body will pop right out. There's a cap on the bottom that you're going to want to remove, and that has 3 spots where it is pressed in, so you just have to keep working it off. If you put the rest of the body into a vise, it'll be a lot easier, and you're less likely to stab yourself with a screwdriver or pry bar. You'll get the pawl will come out, the shackle. You might get the shackle spring. There's a spring that comes off that's held in by that cap, so watch for that. You can now mill all the pieces individually. I wasn't doing super precision work, so I just hand drew all my lines, which is fine for me. And you can kind of see, I cut away some of the front. I wanted a window to see all the flywheels. And then up at the top, I wanted people to see how the pawls and the actuator worked. So here I've got it. I used some parallels to hold the lock high enough. I've got a 3/8 inch end mill set up and to mill the front of the body. I don't remember what speed I was using. I can look that up in my notes later. I had to flip it over because that was too low towards the mill to get the top. So I found some, they're kind of like washers, but they're huge washers for securing threaded rod to a different part of the vise. Got it up high enough, and that's just to take out the little bit of the top to see the pawls. You can kind of see that end mill looks all munged up because I've abused it by just needing to get a project done fast. The bottom cap, I cut a window in there. Like I said before, I started by using a 1/16 inch end mill, trying to cut it, and just found those were snapping, and I was having to stop and wait for Amazon to ship me a new one, and then come back. And when you're paying for day passes, that's not fun, especially when you really want it to be done. So I went to a cutting wheel and Dremel, just set it to 30,000 RPM, and off it goes. It's a balance of how tight you make that vise so you don't crush the cap, and not having it too loose that the piece moves once you've got something moving 30,000 RPM on it. So if you want to get started doing this stuff, I went through a bunch of tools you can use at home. You can buy small mills from Harbor Freight, which is a cheap store. Some people have had success. I've had a lot of people warn me about like buying the power drill there. It lights on fire. A lot of the electric stuff made in China can light on fire. There's a lot of people online doing this. Ask around. If you're doing it on locks, there's a lot of people in Lockpicking 101 making cutaways. At the Makerspace, I took a class. There's other people machining. Everybody was super happy to talk about it and help. Assume the first one is going to suck. And maybe the second one and the third one. I have a picture somewhere if somebody really wants to see later. It looks like something was gnawing on the lock for the first one I did. I all assembled. Measure it again, check that it's flat in the vise. I would try to either put things into a gel for cutting that solidifies if they're an assembled part, or figure out how to take them apart first, because the ones that I tried to cut while they were assembled would move on me, and there were a lot fewer places I could mount them without destroying some of the parts. So as we kind of start to get to the end here, I was on Twitter one day, and somebody pointed this out to me. Some friends of mine at the core group talk about the Master 175 and their physical training, and they were apparently in some sort of military academy, and they said, "Have you ever seen this?" And they were like, "Oh yeah, that's what's on all our rifles." Okay. I hope they changed it after that. I got a lot of help with all this stuff. Artisans Asylum, a bunch of people in the shop. This guy on Lockpicking 101 is the one who came up with the decoding tool. A bunch of my Locksport friends, and some of those pictures came from Deviant's Twitter. Tomorrow, I think the Lockpick Village is probably closed now, but I've got 5 of those cutaways if people want to come see and play with it. I've got a huge roll of feeler gauge if you want to come cut your own decoding tools and play with it. I bought some of the CircleCityCon Easy decoders that you can use to bypass it. You can use the Lockpick Village hooks, just be gentle with them so you don't destroy the hook for people to pick locks. Questions? Passwords?
Thank you.
Yeah.